Let's look at how we use this translation dictionary. I do encourage you to make yourself a little card with what we need to memorize on it. I find it very helpful myself. And let's look at translating f, f prime, and f double prime graphs. So first, let's translate some three-line charts. Translate the three-line chart for f prime of x into three-line, I put that in quotations because they're not actually going to be three lines, for f double prime and f. So given to you in the problem is here. This is f prime. At 2, there's an inflection point, concave up on the left, concave down on the right. At 1, there is a minimum. At 3, there is a maximum. Decreasing, increasing, decreasing. At 0, there is a 0, positive on this side, negative on that side. Now, again, remember, I'm giving this to you. There's no way that you could know that except for the fact that I've given it to you. But what we can do is we can go and we can translate this. So, let's go ahead and put f double prime over here. And all I'm going to do to translate is I'm going to get out my little chart here. And I'm going to say, okay, f prime of x. Anytime that I see that f prime of x is concave up, that translates into increasing for f double prime. So for f double prime, this concave up line translates into an increasing decreasing line. So at 2, on this side, concave up translates into increasing. On this side, concave down translates into decreasing. We can see there's a relative maximum at 2. Now we can do a similar translation. Increasing, decreasing in f prime becomes positive, negative in f double prime. Decreasing translates to negative, increasing to positive, decreasing to negative, and these are zeros. Now let's go the other way. We're going from f prime to f. Notice that we don't have a level. Here's f prime, concave up, concave down. We don't have a level there, so we're not going to put anything there. Just like here, there wasn't a translation from f prime to f double prime, so we didn't have anything right there, just like in language. Now, sometimes things don't translate. So that we can leave blank. But this one, f prime increasing, decreasing, translates into f concave up, concave down. So here's 1, here's 3. Decreasing, concave down, increasing, concave up, and these look like they are inflection points because concavity changes. Okay, for this one, positive and negative translates into increasing, decreasing. Positive, increasing, negative, decreasing. And there we go. We've done our translations. Let's have you try this next one. I want you to translate the three-line chart for f of x into three-line charts for f double prime, f prime, and the integral of f. So you're going to use the entire table on this one. Go ahead and try it on your own, and then start the video again when you're ready. Pause the video now. Okay, so let's look at how all this works. We've got f. Let's go to the right first. So this is going to be the integral of f. Concavity doesn't translate. Increasing, decreasing translates into concave up, concave down. So we've got -1. Increasing becomes concave up, concave up. Notice there is no inflection point here. An inflection point occurs when the function changes concavity. Here it's not changing concavity. This final one, plus minus, translates into increasing, decreasing, decreasing, increasing. Going the other way, f prime. So we know that for f of x, concave up, concave down, translates into increasing, decreasing. Oh, I should have marked over here, there is a 0, or increasing, decreasing, there is a minimum here, even if there wasn't an inflection point up here. So increasing, decreasing, so this is concave down, decreasing, concave up translates to increasing, so there is a minimum. Increasing, decreasing in f translates to plus minus in f prime. Increasing is positive, positive, but there's still a 0 here. And then positive, negative in f doesn't translate. Okay, so the final one, f double prime, we can actually just go straight for doing from f prime to f double prime because we've already done the translation from f to f prime, so it's the same thing to go the next one over. Increasing, decreasing. The next one over is positive, negative. And notice that nothing else translates. So our final answer should look like this. Notice that when we say there's a 0 or a minimum or an inflection point, we need to be very specific about what level of function we're talking about. F prime of x has a minimum at the same value that f of x has an inflection point, at the same value that f double prime of x has a 0. So we can't just say there is an inflection point. We have to say which level has an inflection point.